Okay, we're going to look at solution stoichiometry. So we're going to look at reactions that occur in aqueous solutions and then track the matter through those reactions, like basic stoichiometry. So we've got a solution for this example reaction. A solution of lead 2 nitrate is mixed with a solution of potassium iodide, and a solid precipitate, lead 2 iodide, will form. And then the potassium and the nitrate will remain in solution. They're not really part of the reaction. They're spectators. And of course, to balance this, I've got 1 that's unwritten, 2, 1, 2. And that's how the reaction will occur. For every 1 lead 2 nitrate that reacts, 2 potassium iodides will react, and I will get 1 lead 2 iodide forming as a precipitate, and then 2 potassium nitrates will form. So as stoichiometry goes, of course, if this, we usually count in moles. So if 1 mole of lead 2 nitrate is going to react, I'm going to need twice as much, 1 to 2 moles of potassium iodide. Because for every 1 lead 2 nitrate that reacts, 2 potassium iodides react based on the coefficients. And of course, I would get plus 1.0 mole of my solid precipitate, the lead 2 iodide. And I would get 2.0 moles of potassium nitrate ions in the solution that will remain in the solution. So the reaction says how it proceeds, and then of course the second thing is, well, how much am I actually going to react? So am I going to react 1 mole and 2 moles? Or am I going to react something different, like say I'm going to have 0.50 moles of potassium iodide react with excess. Why do I put excess? Because I have plenty, right? So enough that this is going to be completely consumed. So if that amount is reacted, so let's cross these out because I'm no longer in full moles. Right now I'm reacting this amount. Here's my amounts that are reacting. Then how much lead 2 iodide will form? And we can do this one just in our heads, right? 2 is to 1, so half as much. What's half of this? 0.25 moles of lead 2 iodide will form. The other way to look at it, and we can set up a proportion when it's not, as the numbers aren't as clean as this, 2 is to 0.50 as 1 is to x. 2 is to 0.50 as 1 is to x. When you cross multiply, solve for x, you will get 0.25. Now, of course, what we did previously with stoichiometry, we say, well, okay, well, these are all mole ratios. I need to be in moles. What if I'm giving something like 75.0 grams of potassium iodide? Now, what's my first step? I'm into grams. I need to convert it into moles first, right? 75.0 grams is how many moles? And I'm going to set up the proportion. So pause the video for a minute and try converting your grams, it's potassium iodide, into moles and see if you get the same thing I did. Okay, so when we're given grams, we got to convert to moles. It's a simple proportional relationship. If 1 mole of potassium iodide, I got these numbers from the periodic table. So I said 1 mole of potassium iodide is 166.0 grams. So for every 1 mole, there's 166.0. In a 75 gram sample, how many moles? There are x moles in 75. It's a proportional relationship that we've been doing. It turns out you get 0.452 moles. 75 grams will equal 0.452 moles of potassium iodide. Let's plug that in now. So now that we're out of mass and we're into moles, we can plug it in and do our stoichiometry. 2 is to 0.452 as 1 is to x. And if you solve that, so it's half of 0.452, or 0.226 moles. And that's my relationship that I have. I will form 0.226 moles. I could, in the end, this problem, we don't need to do that. I could actually convert back out and find the moles and find out how many grams that actually is. And let me put a question mark because we haven't do that, and we're not going to do that with this one. Now let's set up a different problem. So if I have the concentration of a solution, we generally don't talk about, well, it contains 75 grams, not usually, because the concentration is a certain concentration. I can use concentration and volume to try the moles, to find the moles. And let's look at a typical problem. So a student mixes 100 milliliters of a 1.250 molar solution of potassium iodide. This would be a typical problem. So I've got I've got a known concentration of solution. I'm going to pour some of that out, measure it, so that I have a known quantity of moles, and then I'm going to add it to a solution. So this one's excess, which means all of the potassium iodide is going to run out because it's got plenty of the other reactant to work with. So I'm given the volume, and I'm given the concentration. And here is our molarity equation. Molarity equals moles over volume. The volume must be in liters for this to work. So let's do that first. Let's convert that 100 milliliters into liters. There is 1,000 milliliters equals 1 liter. I didn't put decimals. It's exactly, right? That's an exact relationship. That's our conversion. So don't limit your sig figs on that one. 1,000.0000 milliliters equals exactly 1.00000 liters. Exactly. So therefore, if I have 100 milliliters, I move this over 3 is going to be our general practice. To convert from milliliters to liters, divide by 1,000 or move it over 3. So using this equation, the moles in my solution, solving for moles, is equal to the concentration times the volume. I'm given a concentration. I'm going to erase this thing. 1.250 molar times, converting to liters, 0.1000 liters. I've got 4 sig figs there, so I'm going to keep my 4 sig figs. I'm multiplying this by a tenth. 0.1250 moles. If I know the concentration and the volume, I can find the moles. In this case, I have 0.1250 moles of potassium iodide. And notice again, I'm not using the 2 yet because the 2 is once I take that and mix it, that's when the ratios go. That's how the reaction proceeds. 1 lead 2 nitrate with 2 potassium iodides. So let's clean this up a little bit. Whoops. And let's look at what we're trying to find. What mass of lead 2 iodide will form? We're going to find the moles first. I just partially wiped my number out. How much potassium iodide? 0.1250 moles. With excess lead 2 nitrate, how much lead 2 iodide precipitate will form? 2 is to 0.1250 as 1 is to x, or half. 0.06250 moles of lead 2 iodide. Now, the problem said what mass of lead 2 iodide will form. So I've got to take that grams and I've got to convert it, the number of moles of lead 2 iodide, I've got to convert it to grams. I've set up a ratio already, 0.06250 moles is to x grams. So now the moles is known, I need to find the grams. If I have 1 mole of lead 2 iodide, and I go to my periodic table, I find the mass of lead, I find 2 iodides, I add them together, and you will get, try that, you will get 461.0 grams. A mole of lead 2 iodide, take the mass of lead, 207.2, 2 iodides, 126.9 times 2, add it all together, you should get 461.0 grams. Cross multiply and do the rounding that we need, and x equals 28.81 grams. That's the amount of solid precipitate that will form. So we started with a known volume and concentration. That gave us the moles. We did our stoichiometry, and then we converted back out in 2 grams. In the next video, we're going to do a couple of practice problems, and you'll want to pause and write down the problem and try it, and then I will work out the solution in the video. So let's try that with the next video.